What I would like to look at next, with the aid of some graphics, is what will these soil particle exchange sites look like in a particular soil if we start out with a soil with a neutral pH, and then as we progress up and down the pH scale, meaning those that are exchange sites in an acid soil versus those in a neutral versus those in a slightly basic, just above neutral ways, versus those in a very strongly basic, which is oftentimes referred to as alkaline type of soil. So let's look at the first graphic on the cation exchange sites and the cations that are being held there in a neutral soil. This first graphic is entitled Neutral Soils. We're letting this figure in the center of this graphic represent a soil particle with negative charges. Remember, these are the exchange sites that occur on the surface of that particle coming from unsatisfied negative charges on the oxygen anions. In a neutral soil, we're showing a significant amount of hydrogen held on these exchange sites, along with exchangeable bases, magnesium and calcium and some potassium. In a neutral soil, the number or quantity of exchange sites occupied by hydrogen will be approximately equal to the quantity of exchange sites occupied by exchangeable bases. In this case, magnesium, calcium, and potassium. So neutral soils, once again, would have an approximately equal number of exchange sites occupied by hydrogen, the acidic soil cation, versus the others here, which are all basic cations, potassium, calcium, and magnesium. There are other exchangeable cations that do not show up here in a neutral soil, and they do not show up because of their lower absorption affinities and/or their inherently low solubilities at this particular pH range. So this would represent a soil around the pH range of about 6.5 to 7.5, or approximately neutral.